Hello friends, my name is Shubham Varadkar. I am a final year B Pharmacy student in Shivajirao at Jondhle College of Pharmacy, Asangao, and I am going to explain about Nmr Spectroscopy under the guidance of Dr. Nmr, Principal and Professor of our college, along with my coordinators Vishakha, Vekhande and Abhishek Tathe. Now let us start. Spectroscopy is the study of interaction of EMR with matter, which may result in absorption, transmission, emission, reflection, and rotation of EMR. Nuclear magnetic resonance spectroscopy or NMR spectroscopy. It is most commonly known as NMR spectroscopy. NMR spectroscopy technique is based on the absorption of electromagnetic radiation in the radio frequency region 4 to 900 MHz by nuclei of the atoms. Proton nuclear magnetic resonance spectroscopy is one of the most powerful tools for elucidating the number of hydrogen or proton in the compound. Spectroscopy determines the physical and chemical properties of atoms or the molecules in which they are contained and provide detailed information about the structure, dynamics, reaction state and chemical environment of molecules. It is used to study a wide variety of nuclei: 1H, 15N, 19F, 13C and 31P. Spin quantum number is related to atomic number and mass number of the nucleus. Element with either odd mass or odd atomic number have the property of molecular spin. If an external magnetic field in applied number of possible orientation calculated by 21 plus 1. Example, hydrogen has spin quantum number 1, which is equal to half, and possible orientation is 2 into 1 divided by 2 plus 1, which is equal to 2. That is half and minus half. Principle of Nmr spectroscopy. The principle is based on the spinning of nucleus and generating a magnetic field. Without external magnetic field, nuclear spin are random in direction. Without B0, nuclei align themselves either with or against field of external magnetic field. If an external magnetic field is applied, an energy transfer is possible between ground state to excited state. When the spin returns to its ground state level, the absorbed radio frequency energy is emitted at the same frequency level. The emitted radio frequency signal that gives the Nmr spectrum of the concerned nucleus and is directly proportional to the strength of the applied field. Nmr spectrum. Nmr spectrum is a plot of intensity of Nmr signals versus magnetic field frequency in reference to TMS. TMS stands for tetramethylsilane. Now, reasons for taking TMS as reference standard: chemically inert, magnetically isotopic, volatile and soluble in most organic solvents. TMS gives an intense. TMS can be easily removed. Electronegativity of TMS is low. It does not make any intermolecular attraction with sample.
Chemical shift. It is the resonance frequency of a nucleus relative to a standard in magnetic field. TMS is the most common reference compound in NMR. It is set at delta is equals to 0 ppm. Delta is equals to V sample minus V reference divided by V reference. Shielding of protons. High electron density around a nucleus shields the nucleus from the external magnetic field, and the signals are upfilled in the NMR spectrum. Deshielding of protons. Lower electron density around a nucleus deshields the nucleus from the external magnetic field, and the signals are downfilled in NMR spectrum.
Factors affecting chemical shift. Factors affecting are electronegative groups or inductive effect, magnetic anisotropy of pi system or diamagnetic effect of pi bond, hydrogen bonding, van der Waals deshielding, effect of temperature and effect of solvent. Now how these factors exactly affect chemical shift? Electronegative groups. Electronegative groups attached to CH system decreases the electron density around the proton, and there is less shielding, that is de-shielding, and chemical shift increases. Below the examples are given. Magnetic anisotropy of pi system. So, magnetic anisotropy means that there is a non-uniform magnetic field. Electrons in pi system, example aromatic, alkynes, alkenes, carbonyls, etc., interact with the applied field, which includes a magnetic field that causes the anisotropy. It causes both shielding and de-shielding of protons. Example benzene. Van der Waals deshielding. The electron cloud of bulkier group will tend to repel the electron cloud surrounding the proton. Such a proton will be deshielded and will resonate at slightly higher value of delta than expected in the absence of this effect. Effect of temperature. Resonance position of most signals is little affected by temperature. Effect of solvent. Chemical shift changes when the solvent changed from CCl4 to CdCl3 in 0.1 ppm, but change to more polar solvent like methanol, the change is 0.3 ppm. Solvents used in NMR are CCl4, CS2, CdCl3, C6D6, D2O, hydrogen bonding. Protons that are involved in hydrogen bonding are typically change the chemical shift values. The more hydrogen bonding, the more proton is de-shielded and chemical shift value is higher. Proton Nmr. The most common form of Nmr is based on hydrogen 1, that is 1H, nucleus or proton. It can give information about the structure of any molecule containing hydrogen atom. Example ethanol. Interpretation of 1H Nmr spectra. Number of signals indicates how many different kinds of protons are present. Position of a signal indicates something about magnetic environment of proton. Relative intensity of signal proportional to the number of protons present in signal. Splitting of signal, that is spin-spin coupling, it indicates the number of nearby nuclei, usually protons. N plus 1 rule. The multiplicity of signal is calculated by using n plus 1 rule. This is one of the rules to predict the splitting of proton signals. It is considered by nearby hydrogen nuclei. Therefore, n is equals to number of proton in nearby nuclei. 0 hydrogen atom as neighbor. Then n plus 1 is equals to 0 plus 1, which gives 1, that means singlet. 1 hydrogen atom as a neighbor. Then n plus 1 is equals to 1 plus 1, which gives 2, that means doublet. 2 hydrogen atom as neighbor means n plus 1, which is equals to 2 plus 1, which gives 3, that means triplet, and so on. Spin-spin coupling means splitting. The interaction between the spin of neighboring nuclei in a molecule may cause the splitting of NMR. The splitting pattern is related to the number of equivalent hydrogen atoms at nearby nuclei. Example ethyl acetate. Spin-spin coupling. With the example of ethyl acetate, we will understand the spin-spin splitting patterns. First, singlet. 3 equivalent proton not coupled to any neighboring proton. Quadret. 2 equivalent proton split because coupled to 3HS at the 2 position. Triplet. 3 equivalent proton split because coupled to 2HS at the 3 position. Rules for spin-spin coupling. Chemically equivalent protons do not show spin-spin coupling, and only non-equivalent protons couple. Protons on adjacent carbon normally will couple. Protons separated by 4 or more bonds will not couple. Here the examples of splitting observed and splitting usually not observed are given. Origin of signal splitting. The origin of signal splitting pattern in which Each arrow represents a Hb nuclear spin orientation. Coupling constant. Measurement of splitting effect is based on the distance between the peak in a given multiplet, usually in one edge Nmr of complex structure.
Instrumentation: sample tube, sample holder, permanent magnet, magnet coil, sweep generator, radio frequency transmitter, radio frequency reviver, readout system. Sample tube, sample holder. It should be chemically inert, durable and transparent to Nmr radiation. Generally about 8.5 cm long and approximately 0.3 cm in diameter is employed. Sample probe. It's the device that holds sample tube in position and is provided with an air drive for rotating the sample tube almost 100 revolutions per minute. Permanent magnet. It provides homogeneous magnetic field at 60 to 100 mHz ABC. Magnetic coil. It induces magnetic field with current flow through them. And sweep generator to produce equal amount of magnetic field passed through the sample. Radio frequency transmitter. Transmitter is fed onto a pair of coils mounted on right angles to the path of field. 60 MHz capacity is normally used. Radio frequency receiver. Detect radio frequencies emitted as nuclear relays at lower energy level. Signal detector and recording system. The electrical signal generated is amplified by means of amplifier and then recorded. Applications: 1H Nmr used for structural elucidation of organic and inorganic solids. Nmr is used to determine the physical and chemical properties of atoms. Applications in medicine: it is used as anatomical imaging, used in measuring physiological function, flow measurement and angiography, tissue perfusion studies, used in tumors and MRI. These are the references. We are thankful to our President Dr. Shivajirao Jondhle sir, our Secretary Dr. Geeta Khare ma'am and our Principal Dr. Nitin Mohire sir. Hope you like this video. For more informative videos, subscribe to our YouTube channel.